Welcome again. Today we visit our closed system mesocosm to make another observation. Here we can see three kinds of photosynthetic organisms. Algae forming a thick mat at the bottom, with mosses at the extremities of the rocks, and even a fern growing at the top of one rock. Algae dominate the waterlogged bottom. This observation leads to the question: do mosses like high humidity and moisture, but prefer good drainage? Let's go out into the field and see what we find. As we go into the field, we ask the question: is moss found with a greater frequency in well-drained areas of their habitat? Here on the island of Trinidad, we see algae growing on a mound of sand. And here, algae in this wet drain, with mosses growing in the cracks, the drier areas of the habitat. Here in Wuxi, China, we see at the root of this tree algae in the wet areas and mosses on the drier parts of the root. Here at Shanghai American School, in this hollow area of soil, we see algae growing. But here in this well-drained area, we see moss. So with this set of observations to back up our initial question and observation from the mesocosm, let's visit the literature and see what we find. And here in this document from Clemson University, we see some support for our hypothesis. So here in the field, we choose several plots which are frequented by moss, and we follow a sampling protocol using a grid or a tiny quadrant, and we create an imaginary x and y axis in our study area, and we find coordinates at random and place our tiny frame or quadrant to determine the presence or the absence of moss in the sampled area and whether the area is well drained or poorly drained. But to select our points, we use a random number generator. And then we make up a contingency table, a 2 times 2 contingency table, like this. This table allows us to run the chi-square test using this online calculator. And provided that we have taken sufficient samples, then the output from the chi-square test would generate a p-value, which, if it comes to below 0.05, would allow us to conclude that the alternative hypothesis is to be accepted.